Alright, John, so then the only last thing that I need to tell you from this part of the chapter is that you can now do homework number 76, which is workbook page 371 through 372, numbers 3 and 4a, except for 4a is going to tell you to graph between, I think, negative pi and positive pi. We only want you to graph between 0 and 2 pi. Okay, so just take note of that for your homework. We only want you to graph between 0 and 2 pi. Okay, so that's homework number 76. And I'm really sorry that I still don't have the notes from Miss Tompkins for this section. I don't know why I thought I grabbed all of the ones from her, so I don't have the notes, but just bear with me, okay? Alright, the next section that we're going to do is called, let me just write it over here, is called amplitude, period, and horizontal shift. Okay? So that's what we're going to do now. That's the next section. And let's see what Miss Tompkins has us doing. Okay, so on the first set, or on the first slide, and I think that you actually have these printed off as well if you want to go along and do it with me. She says to use your graphing calculator, and we're going to graph a bunch of different sine curves all at once, and these are going to be the sine curves. We are going to graph y is equal to sine of x, we're going to graph y is equal to 2 sine of x, we're going to graph y is equal to 1/2 sine of x, and then I believe the last one is 4 sine of x. Okay. So the point of this is to figure out that number out front, how it's changing. Like what happens to the graph of sine of x if we change the number that's out front. Okay, so Ms. Tompkins had you guys in class go through and actually put all these into your graphing calculator and then pick which one showed on the screen at once. But I have this really cool app, and it's called the Transformation app. And what you do is you type in this equation. And you know what? Actually, I think I'm going to clear it. Let me see what happens if I just do a sine of x. And then I graph. Okay, so what this app allows me to do is, you see how it has a is equal to 1 right here? That's this one. Y is equal to 1 sine of x. And what it's going to allow me to do is, as I change that 1, it's just changing that part out front, so we're going to see the difference. It might be helpful, it might not be, I don't know. So this is what the normal sine curve looks like. Y is equal to 1 sine of x, or just sine of x. So let's see now what happens if we do 2 sine of x. So let's change that a equal to 2, hit enter. And then all of a sudden, that sine curve got really, really tall and really, really short. So if you look at what happens, we're still looking at the exact same window. The sine curve still starts at 0, it still ends at 0, it goes through 0 halfway in between. But when it hits its max, it's really, really tall, and when it hits its min, it's really, really short. Let's see what happens if we change that a to 0.5 or 1/2. Enter. Alright, so now it looks like the same sine curve to me. It still starts at 0, ends at 0, goes through 0 in the middle. But when it reaches its max and when it reaches its min, it's halfway, it's shorter than what it used to be. So I guess by now you can probably figure out what happens if we do 4. So y is equal to 4 sine of x. Gets really, really tall. But the important thing to remember is that the sine curve is still going through the exact same points. It's still starting at the same point, ending at the same point, going through the middle. What do you think is changing when we change those numbers out front? And what's changing is the height or the amplitude of that graph. Okay, so How is the graph y is equal to sine x affected? It's changing the height. Okay, so let's type this out. Let's type out what we figured out. Okay, the standard form for a trig graph is y is equal to a sine of bx and y is equal to a cosine of bx. So what we just figured out, we were just analyzing what that a term with the number out front does, and we call that the absolute value of whatever that a is the amplitude. And what that means is if there was a -2 out front, its amplitude or its height would still be between 2 and -2. The negative out front really just tells you which direction it's going first, and I'll explain that a little bit later. But right now, all you need to know is A, the amplitude, is the absolute value of half the distance. I'm sorry that I can't type. Of half the distance between the max and min. So let's take a look at what I mean by that. The absolute value of half the distance between the max and min. Well, if you go back and look at our calculator, this is telling us that the amplitude is 1. Okay? That means that it's half the distance between the max and the min. That means that the max up here is at a +1. The minimum right there is at a -1. So the total distance between the minimum and the maximum right now is 2 because we go up 1 and we go down 1. So the amplitude is half the distance between the max and the min. Another way of thinking about it is it's kind of like the height. It's wherever you're starting, the amplitude is how high up you're going to go, and then you're going to go back down to 0, and then the amplitude is how low you're going to go, and then come back up to 0. Okay, so hopefully that helps. So then it tells us to take a look at the model problem in your workbook on page 374. So you can either grab your book or you can try to look at my book if you can see it. Okay, so model problem on page 374. So I'm going to see if I can see this at the same time as you. So given the function f of x is equal to 3 sine of x, what is the amplitude? Does that say amplitude? What is the maximum value of f of x? So given the function f of x is equal to 3 sine of x, what is the maximum value? Well, you're going to figure that out by looking at the number right out front. Because that says 3 sine of x, that means that our maximum value is +3, and our minimum value is -3. Okay? Number 2. Which function has a minimum value of -2? Which function has a minimum value at -2? Well, that means that the number out front has to be a 2. So y is equal to 2 sine of x means that the maximum value of this is +2, and the minimum value is -2. So that's your answer, choice 2. Let's go down here to number 3. Okay. Which graph shows a function with an amplitude of 1/2? So this is just taking a look at the pictures. So the amplitude is how tall it goes. So you can see that this one goes all the way up to 1, so that's not it. This one goes all the way up to 2, so that's not it. This one over here, it looks like it reaches its maximum and minimum of 1/2, so that looks like that could be the answer, because that one looks like it reaches a maximum of 1.5. So this is our answer, choice 3. Okay? So you can take a look at that stuff in your book too if you couldn't really see that. But those are the 3 questions on page 374. Okay. Alright, let's see what else. Alright, now what we're going to do is use our graphing calculator again. And this time we are going to graph 4 more functions. We are going to graph y is equal to sine of x. And by the way, the amplitude thing works the same way for cosine as well. It's not just sine, it just happens to be them using sine as just an example. Y is equal to sine of x. Y is equal to sine of 2x. So this time we're kind of exploring what happens with that number that's right next to the x. Y is equal to sine of 0.5x. And y is equal to 4x. Or sine of 4x, sorry. And before I do that, I'm just going to come over here and change my window between 0 and 4 pi, just so that we can get a little bit bigger of a picture, a little bit bigger window to look at. Okay, so when you're looking at this graph, it's between 0 and 4 pi. So you're going to see two full sine curves between 0 and 4 pi, because this is one full sine curve. It goes up, then it goes down, then it stops right here. So this is one full sine curve, and then you're going to see a second full sine curve. Up, down, stop. So you see two full sine curves right now. Alright, so the first picture that we have is just y is equal to sine of x. So if you want, you can only look at that portion right there, if that helps you. Now let's see what happens when we look at sine of 2x. And I actually do have to go and change this. Now we're going to change it to a sine of bx, because we're going to be changing that b. No, I do not want to change my color scheme. Okay. Graph that. Now we just have the option to change that b as well, which is kind of cool. So that b is the number right here that's next to the x. So the first thing that we have is y is equal to sine of x, which looks like this. What happens if we change that b to be a 2? Oh my gosh. We see lots and lots of things going on. Maybe changing that window didn't help very much. You know what? Let me get out of this app and change it, uninstall. Let me see how much time I have left. A couple minutes. Alright, let's just do it the way that Miss Tompkins did it in class. Maybe it'll be easier for you to see. So I'm going to graph y is equal to sine of x. I'm going to graph y is equal to sine of 2x. Y is equal to sine of 0.5x. And sine of 4x. And you can do this on your calculator too if you want. I'm going to change that window back to 2 pi. Just because I think it's what you're used to, and I don't want to confuse you at this point. Okay, so let's graph that. Oh my god, it's graphing all of them. No, I don't want that. Why? Alright, so let's just graph. We know what the first one looks like. Let's move our cursor down so that we're not graphing the third or the fourth. So what we're looking at right now is we're going to take a look at the first sine curve and then sine of 2x. So this is our first sine curve. It just goes up, comes back down, and it stops at 0. Now this is my sine of 2x. So it goes up, down, stops at 0, up, down, stops at 0. So how many full curves do you see between 0 and 2 pi? Well, for this one, I only see one full curve. For sine of 2x, I see two full curves. Now let's go and graph sine of 0.5x. Let's graph that and see what we see. This time, how many full curves do you see? I only see a half of a curve. I only see it going up to its max and down to 0, but I don't see its minimum. See, we're missing the valley down here. So that's what y equals sine of 1/2 x looks like. I only see 1/2 of a curve. So then I'm pretty sure that you could probably figure out by now what happens if we graph sine of 4x. If we do sine of 4x, you're going to see four full curves. So you go up, down, 1, up, down, 2, up, down, 3, up, down, 4. Okay, so we see 4 full curves. Let me see if I need to stop this right now. And I do. Okay, I will be right back.